All right, good morning, grade 7, if it's morning when you're watching this video. I hope yesterday's math lesson went well for you. It was great that I could chat with some of you when you had questions. Keep that up. Make sure before you ask me a question on the chat that you have clearly read all the instructions, whether that's on the to-do list or on the actual assignments page. I find that a lot of your questions can be answered just by double checking what does the assignment actually say. Here's our outline for today's lesson. Again, it covers a lot of different things. So I've outlined it for you, the 6 different things that we're going to cover. Some of it is review, so I'll go through it more quickly, but some of it is completely new to us. So first, let's take a look at what is a rational number. Now, a rational number, we actually learned about this all the way back in probably the first or second week of school. So you remember we talked about counting numbers, whole numbers, integers, and rational numbers. So counting numbers are numbers like 1 or 4 or 5. Whole numbers are all the counting numbers plus the number 0. Then we have integers, which are basically the whole numbers, but then you also can have negative numbers. Okay? And then we have rational numbers. Now, basically, just to keep it simple for today, rational numbers are any numbers that can be expressed as a decimal that is either terminating or repeating. It can be a whole number. It includes all of the things. It includes integers, it includes whole numbers, and it includes counting numbers. So pretty much rational numbers are the numbers that we work with in day-to-day math. We don't often think about them as being rational. Now you'll remember irrational numbers, our prime example of an irrational number was pi, okay? And we often say that pi is 3.14. That's just our summary. Pi goes on for forever and it doesn't stop, so that makes it irrational. So basically you can just think to yourself, a rational number is the numbers that I work with in day-to-day math. Right, in order to do these next few lessons in this unit about rational numbers, you need to be able to change from decimals to fractions. So here we have the decimal. 0.2 is what we like to say, but the real way that we should say it is 0 and 2/10. If you say it the real way, you can hear yourself say 0 and 2/10. So we can very simply put it into a fraction, which of course we can simplify. What number can I divide 2 and 10 by? I can divide 10 by 2 and I get 5. What I do to the bottom, I must do to the top. So I divide it by 2. So I can do the same thing over here and I get 1/5. Okay, so that's from a decimal to a fraction. Now if we take a look at the next one, if I say it properly, it's 0 and 825 thousandths. So I can go ahead and write it like this. 825 thousandths. Now again, whenever you're working with fractions, think to yourself, I want to put it into simplest form. So I think, what can I definitely divide both of these numbers by? I'm going to try dividing by 5 because I know that that will definitely work. So 1,000 divided by 5, I happen to know is 200. Then again, don't be afraid to go to the side of your math journal. You can do some long division for a minute. I'm not so fast with the stylus, but we'll figure it out. 6, 30, 2, 5, 5. So I get 165 200ths. Now again, I can probably make it simpler. So I'm going to erase my work from over here just to give myself a bit more room to work with. And I think I'm going to divide by 5 again, just because I'm confident that both of those will fit into 5. So I think to myself, okay, 200 divided by 5, well, I can just cross out the 0 for now. What's 20 divided by 5? It's 4. Put the 0 back on. 165 divided by 5. Number on the top goes in the box. So I get it goes in 3 times. Again, don't mind how messy I am with the stylus. And I get it in simplest form. Okay, so that's just a brief review on switching from decimals to fractions. Now, you guessed it, we're going to talk about changing fractions to decimals. So if you look over here, I have 4/5, and I can think to myself, how can I put that into a decimal? Well, I can think of it in terms of tenths or in hundredths because I know that that's how decimals work. So I can think to myself, I'm going to put it into tenths. How did I get from 5 to 10? Well, I multiplied by 2. What I do to the bottom, I must do to the top. So I end up here with 8 tenths. It's still a fraction, but I should be able to say 0.8, or really 0 and 8 tenths. Now I have 7/8. And I'm sure you're thinking, but Miss Nyaf, I can't make 8 into a 10 by multiplying it. So I have a couple different options, okay? The first thing I can do is I can just think, well, 7/8, a fraction, I can divide that. So I can go over here, number on the top goes in the box. Now you can think, 8 does not fit into 7. Not a problem, because I can place a decimal. 8 goes into 7 0 times. 8 goes into 70 how many times? I'm drawing a blank. How many times does 8 go into 70? I don't have anybody to help me here. I'm going to go with it goes in 8 times. So I get 64. Then I have 6 left over. Add a 0, bring it down. 8 goes into 60 7 times. 56. 4. Bring down a 0. 8 goes into 40 5 times. So I get this decimal, 0 and 875 thousandths. Okay? All right, the next part of our lesson is comparing integers. I wanted to review this because I wanted to remind you the way it works with negative numbers. Okay, so let's say I'm going to start with 0. I'm going to place that on my number line right here. Then I'm going to start with all my positive numbers because they should be pretty straightforward to me. So I'm going to place 4 over here and 6 over here. Now what I want to emphasize here with negative numbers, you need to think to yourself that -3 is actually smaller than -2. Okay, because think about being in debt. Would you rather lose $2 or you'd rather lose $3? Okay, you'd rather only be $2 in debt than $3. Okay, so I can place this here. So I've done that one, that one, that one, that one, that one. Now, -0.5 or -0 and 5 tenths fits nicely in between here. So we have our -1 and 0. I could place it right in here. I don't quite have the room. Okay. So when you're thinking about integers, think carefully about which direction our negative numbers go. Okay, now we're talking about ordering rational numbers. So let's say I wanted to put this in order from, let's do from least to the greatest. From least to greatest. In order to order rational numbers, I need to be able to compare them pretty easily. So I'm looking here and I notice that I have a fraction, a fraction, and a fraction. And then I also have a decimal, okay? So they're all working in different forms. But why don't I just start by comparing these two fractions first? So I can think to myself, 2/4 I have, and I have 3/10. How could I easily compare them if I wanted to see which one was bigger? Well, if I wanted to, I could put them both out of a denominator of 20. So 4 times 5 is 20, 2 times 5 is 10. So I get 10/20. Okay, and then here again, I went by 2 and I get 6/20. So I automatically know that my 2/4 is bigger than my 3/10. I'm going to run out of room, but let's see if I can squeeze this on a number line. Or if I wanted to, actually, I won't put it in a number line. We'll just put it in order. So I'm going from least to greatest, so I can start by saying that 2/4 is one of my bigger ones. So I'm going to put it down here. And then I know 3/10 is smaller. I'm going to leave some space in between. Now let's go back, let's see if I can switch the color, to thinking about my decimal here, 0.8. Well, we just talked about how can you put decimals into fraction. Well, 0.8 is 8 tenths. Okay, that's handy. It's already in tenths. So I should be able to compare between 3/10 and what I know as 10/20. I know that 8/10 is definitely bigger than what I have over here. 8/10 is bigger than 3/10. 8/10 is also 16/20. So that's my biggest number so far. So I can put that over here. I could write it as 16/20, or you could think to yourself 8/10. Now you might be thinking to yourself, but Ms. Nyhoff, what do I do with -7/23? How can I put that into tenths? Well, I put it on here just to prove a quick point. I don't actually need to put it into tenths to know that it's the smallest number. Why do I know that it's the smallest number? Because it's negative. Okay, so when you're looking at ordering rational numbers, think carefully about what you actually need to know. So in this case, it's okay that I didn't change this form of my number because I already know it's the smallest one that's there. All right, if you're finding this is a lot of information, the handy thing about YouTube is you can just pause the video and come back to it later. We have 3 more slides to go. All right, this is also new to you. This is talking about equivalent forms of rational numbers. So when we look at rational numbers, we can look at them in a variety of different views. For example, I have 4m divided by 3. What is equivalent to that, so a different way of writing it that means the same thing, is this. I could write 4/3 times m. That's the same thing, because if I wanted to, I could just do 4 times n divided by 3. It's the exact same thing. I could also write this in a different way. I could also write that it's also equal to m times 4/3. Okay, that's another way that I could write it out. However, this is important. It does not equal, remember that's my not equal sign, it does not equal the same thing as 4/3m. Okay, that would actually change what's happening. So these two over here are equivalent. It's just a different way of writing it. Let's talk about another one. What if I wrote 8m/6? Would that be equivalent to what I originally wrote over here? Would this and this be equivalent? Well, I can think of them in a sense as equivalent fractions. I could think about getting rid of the m for a second and think to myself, is 4/3 and 8/6 equivalent? Well, let's think. I can go 4 times 2 is 8, and 3 times 2 is 6. So yes, this one is also equivalent. Now let's think about that when we're working with negative numbers. Okay, so we have -2/3. You have to think back to our integer unit about what the rule is with dividing with negative numbers. So -2/3 is the same as -2 divided by 3, because when I have a negative and a positive together, opposite signs, I do end up with a negative answer. That means it's also the same as 2 divided by -3. Again, positive, negative, they're opposite. I end up with a negative answer. Now, you must think to yourself, why does that matter? It matters because this right here does not the same. It's not equal to -2 over -3. Well, why is that? Well, remember, back to our integer unit, a negative divided by a negative actually gives me a positive, okay? So that's why these two things are not equal to each other. You have to think about the negative sign. All right, one last thing, okay? Evaluating expressions. We haven't talked about evaluating for a while, not since our algebra unit. Remember, evaluate does not mean solve for m. You're not required to figure out what m is because we are told what m is. So evaluating the expression is figure out what this is if m is -4. So I can do that quite simply. the first thing I do is where m was, I put my number. I've been told that if m is -4, so I put it there. So now I have this. 6 times -4. Again, think back to our integer rule. 6 times -4. Well, 6 times 4 is 24. Positive or negative? Well, I have a positive and a negative, so my answer is going to be negative. So I have -24/15. Now I can simplify. Move it down a level. So I'm going to simplify. I know I have 1 whole pizza, because I'm taking 15/15, and then I have 9/15. But remember, it's negative. Do not forget about that negative sign. And then I can think to myself, I can probably simplify that further because I know that 9 and 15 can both be divided by 3. So I get 1 3/5 with also, sorry, it's getting a little messy, with the negative sign. Okay, that's evaluating an expression. So hopefully I've gone over all the different types of questions that you need to know to do lesson 10.1. If it helps you, you can always watch the video again. That's the beauty of YouTube, that you can basically listen to me explain it over and over again. But if you get stuck, feel free to chat with me tomorrow. Remember, I'm mostly available between 9 through 12, 9 a.m. to 12 p.m. So if you message me at 3 in the afternoon, I might be busy making a YouTube video, so I can't always reply right away. So my suggestion is that you get your math lesson done on the earlier side.